Okay, well, I sent out the email, but I don't have any new viewers yet. Just give it one more minute before I start. Okay guys, so it looks like a few of you have found us. I'm going to go ahead and get started now. My microphone might not be as good as Dr. Turley's microphone because I'm just using my laptop now. His camera wasn't working, so that's why we're doing it on mine now. So please do send me an email if you are not able to hear me or see me, or if you have any comments or questions or anything like that. I'm gonna put my phone up here on volume so that I'll hear any new emails coming in. Okay, so I'm gonna go ahead and get started. So we're gonna be going over problem set 7 tonight, and I got a lot of questions about the review questions, so I'm gonna start with those. In particular, review question number 3 was most requested, so I'm gonna start there. Okay. So if you want to head there right now, it's the short run versus long run production. I'll go and just read the question right now, but it says, consider the following production costs for the Louisville Sluggers, calculate the marginal cost. And then we have this table right below that has employees per day, bats per day, average variable cost, and average total cost, and then we're supposed to fill in marginal cost. So this is actually a little bit tougher than the other tables that you have seen like this one, because normally you have more columns than this, and you would actually probably need to use more columns than this to come up with the marginal cost column. So that's what I'm going to do. Even though he didn't give us a bunch of extra columns, I'm going to calculate 2 new columns, which is going to be the marginal bats produced per an additional employee, which I'll show you in a sec, and then a total cost a total cost column as well. And then with those, we'll be able to calculate the marginal cost. So I'm going to get started on doing that. Would you mind reading the information that it looks like? Yeah, almost per day. Oh, so for you then, or oh. exclude, and then that. So wait, this is that per day, right? It must be, okay, that's okay. So I guess that is marginal bats then. Okay. Um, so, okay, and then we have total. Oh, wait, yeah, okay, it does. So after this, guys, I hope you can see that back there. I've given you all the columns that he gives us with the values filled in. And so finally, he wants us to calculate marginal cost over here. But I'm actually going to put one more column in between. And I'll explain why. Okay. Okay, so I'm a little bit unclear on the wording of this problem, and so I'm just going to do my best to calculate it the way that the way I'm understanding it. Let me take a look here for a second and just make sure. So just to explain kind of what I'm thinking, my confusion is whether the bats per day represents the marginal bats per day, or whether I should take that as a total bats per day and calculate my own marginal bats per day. Yeah, I think I need to calculate my own marginal bats per day. So right now we have, when 0 employees are working, we get 0 bats. When 1 employee is working, we get 40 bats per day. But then when we up it to 2 employees per day, we get an additional 60 bats per day. So it goes up to 100 bats per day. And so I want to find out what the marginal bats per day is as I add on additional employees. So I'm just going to, normally you would create a new column for doing this, but I'm actually just going to put in green in between bats per day what the marginal increase is. So I'm just going to do, 40 minus this area right here. So 0 to 40, we're increasing 40, 40 to 100, we're increasing 60 per day, 100 to 130, we're increasing 30 per day, 130 to 150, we're increasing 20 per day, 150 to 165, we're increasing 15, 165 to 175, we're increasing 10, 175 to 181, we're increasing 6. Okay, so normally, how do we calculate the marginal cost? How do we normally do that, John? Do you remember? Okay. Yeah, so it's difficult. So it's difficult to figure out with just the columns that he gives us what the marginal cost should be, which is why I added in a new column, which is this total cost column. Because normally, when we calculate marginal cost, we want to know the change in total cost, and we want to divide that by the marginal product that we're producing. So we want to know how many additional dollars we're spending and how many divided by the number of additional products that we're getting out of that expenditure. And so, but we don't have any of these columns here that he gave us. None of those columns would give us the variable cost between, or the increase in total cost between one level of production and another. So, because we only have average total cost, we don't have regular total cost. So in looking at this, you might, when I was looking at this problem, I thought, okay, can any of this information provide me with the total cost of production? And so I thought about what I would have to, it doesn't give it to me. It doesn't give me the total cost of any certain one of these employee levels. But if I do some math, I can actually come up with it using this information. So if I want to come up with the total cost, what I would do is I would multiply the average total cost. So that's like the average total cost of any one particular item, and multiplying it by the number of items. So for instance, when there's one employee per day, you get 40 bats, and each of those bats costs $2.6 dollars. So you look at the bats per day, you get 40, and the average total cost is 2.6. And so I'm just going to multiply those together to get the total cost for that day. And I've already done the math for all of these, so I'm just going to multiply the bats per day times the average total cost to get the total cost. And then from there, I can get how much the total costs are increasing, and I can calculate the marginal cost. So that's what I'm going to do. Okay, so 40 bats per day times 40 bats per day times 2.6 for an average cost is 104. Yeah, for the total cost. So, and then for 2 employees per day, it's going to be 100 times 1.28, and that's going to give us 128. For 3 employees per day, it's going to be 130 right here times the average total cost 1.169, which is 151.97. I'm going to keep calculating that way. One second. One minute. Okay, so now to come up with the marginal cost for BAT, I'm going to use the, I still need to know how much my marginal costs are increasing and how much my marginal BATs per day are increasing. So I'm going to use, so I'm going to, first I'm going to calculate the marginal increase in cost, and I'm going to just put those values in purple in between these green values, and then I'll go from there. So when I go from 0 to 104, 104, 24. Okay, so I just finished calculating the total, the marginal, or I guess it's the variable costs. And I calculated those in purple on the total cost column. So now when I want to calculate the marginal cost of producing one additional bat, I'm going to look at the marginal increase in cost and divide it by the marginal increase in bat. So change in total cost and divided by the change in number of bats per day. Yeah, so it's going to be this value and this in purple divided by these values in green. So 104 divided by 40. So here it's going to be 2.6. So here it's going to be 24 divided by 60. So that's 0.4, 23.97 divided by 30. So that's about 0.8. You know what? I'm just going to calculate this. These are all 24. So, okay, so 24 divided by 20. 1.2, 24 divided by 15 is 1.6, 24 divided by 10, 2.4, and then 24 divided by 6 is 4. So that's the marginal cost for additional, for producing additional batch. Is that making sense? So just to summarize and recap, I copied the table that he gave us, but I included a new column in which I have the total costs and the marginal or the additional costs going from one level of employees to another. So in green, I have the total cost, and then this purple number represents the difference between the previous amount of total cost and the new amount of total cost based on the new number of employees. So 104 to 128 to 24, etc. So once I have the change in cost, and I also have over here in green the change in bats per day, I could calculate the marginal cost column. So that's how I did that. What's that? Well, I just asked them to send me an email if they have any questions. I haven't. Well, we should all have my email. All right, guys. So we filled in the column. Now we're going to move on to part A. It says, what is the lowest price for which Louisville Slugger will operate in the short run? How many bats will they produce at that point? So they will produce at the lowest price where their marginal costs are being covered. So I might have to graph this first. Okay, so I might actually do part C first so that we can look at part A and part B and make a little bit more sense of it easier. So I'm going to sketch the average total cost, average variable cost, and marginal cost curves on a graph. So I have quantity bats along the x-axis, and then price along the y-axis. I'm going to start with uh, 4, 1. Okay. So I'm going to start with, so this one is going to be in purple over here. So let's see here, when I have, I'll just, okay. So I have, see here, 40 bats per day. I'm going to have an average total cost of 2.6, so somewhere about right there. When I have 100 bats per day, I'm going to have an average total cost of about 1.28, so about right here. 1 point, so when I have 130 bats per day, I'm going to have about 1.169. 150 bats per day, it's going to be 1.173. When I have 165 bats per day, it's going to be about 1.4. 175 is going to be about 1.28. And then at 1v1, it's going to be about 1.37. So that's the average total cost curve. The average variable cost curve is going to be in blue. So at those same points with 40 per day, it's going to be 0.6. With 100 per day, it's going to be 0.48. With 130 per day, it's going to be 0.55. 150 going to be 0.64. 165 is going to be 0.73. One step with 175 is going to be 0.82. And then 180 is going to be about 0.99, about 1. So this is our average variable cost curve. And then I'm going to do the marginal cost curve in green. So it starts out up here at 2.6, just like this one. At 40, and then at 60, or sorry, at 100, it goes to 0.4. At 130, it goes to 0.8. At 150, it goes to 1.2. At 165, it goes to 1.6. At 175, it goes to 2.4. And then at 181, it shoots all the way up to 4. So this is our marginal cost curve, something like this. Yeah. Oh, I should make it. Okay, so now I'm going to go back to part A. What is the lowest price for which Louisville Slugger will operate in the short run? How many bats will they produce at that point? So in the short run, they're only going to produce if they are covering at least their variable costs, right? Only if they can pay for the price of employees are they going to operate in the short run, and if they can make up some of their costs that way. So we want to find a place on our graph where that's true. So where is it the case that on the upward sloping part of the marginal cost curve, you will be covering our average variable costs. Yeah, it looks like it'll be about right there, right? Which is maybe about 115 or 120. So this is where our marginal cost curve intersects with the average variable cost curve, this blue one, on the upward end of it. Because if they were producing right here, they would continue producing because there's economic benefit down here to gain. The marginal cost is still decreasing. So yeah, so it looks like according to the graph, they would produce about 100. At this, they produce about 115 bats, and it would be at about, let's see, what quantity would that put us at? At about 100. 100, 130. We want to find what price point this spot right here is at. We don't have the equation for the lines, but we do have this graph. And so we would just estimate about where we think that this line, we'd just estimate what we thought the price looked like it was about at this point right here, where the marginal cost curve is intersecting with the other variable cost curve. Yeah, it looks on my graph like it's about 0.5. I tried to draw as much to scale as possible, but so what is the lowest price for which the Louisville Slugger will operate in the long run? How many bats will they produce at that point? So in the long run, they're going to be looking at their average total cost curve. which is this purple line. And so they will produce at a minimum cost where their marginal costs are, sorry, where they will produce at a price point where at least their average total cost is being covered in the long run, if they decide in the long run. So they wouldn't produce anywhere, they would produce no lower than this point right here. Yeah, it looks like the quantity would be about 150 maybe, and then the price over here would be, let's see, what is the price over there at about 150 for that? About 1.17. I don't know, just about, just estimate, I think, in this case. But they wouldn't want to produce anywhere below the average total cost. They want to at least cover their average costs in the long run. So now we've done parts A, B, and C. So if you guys have any questions, you can email me real quick. I'll just write my email to the board. I think you guys all have it. So if you can see my email over there, just bailey.ab@gmail.com. Shoot me an email if you're having any issues or if you have any questions. What did you think of that, Don? That makes sense? Okay. I was just wondering what it was. I was just, it was okay. Okay, guys, I haven't gotten any email questions. I mean, feel free to also email me if you just can't hear. I don't know how my microphone's doing compared to Dr. Turley's, so just let me know. I'm trying to talk loud, but I can talk louder if I need to. Otherwise, I'm just going to move on to review question number 1 now, Post theorem. Read it. So the MPAA wants to organize a turkey bowl in which students play flag football together. If the MPAA were to conduct the event, $1,000 of surplus would be created. So $1,000 in surplus will be created from the turkey bowl if it's held. BYU, on the other hand, doesn't want the MPA to have sponsor a football event because then the university is legally liable for injuries that are sustained during that event. An expectation allowing the MPAA to hold the event would result in a 5% chance of someone sustaining an injury that costs the university $18,000. That's what we have. 5% chance of getting an $18,000 injury. Assume the university is risk neutral, so the expected value of the injury is simply the size of the loss times the chance of it happening. We don't need to use any like risk aversion coefficient or anything. So that means that the, let's see here. So that means that the value of the risk then would be 5% times 18,000. Risk value is 18,000 times 5%. John said 900. Okay, so part A says, is it socially optimal to hold the football event or to not hold the football event? Since we see that $1,000 in surplus will be created, and you have to subtract the risk value, which is 900, we see that we still come out on top by $100 if we hold the event. So socially optimal to hold the event is what that means. Part B says, who bears the higher opportunity cost of not getting their way? This is kind of a funny, tricky question, but it's actually just another way of asking part A. Whoever bears the higher opportunity cost is, whichever option bears the higher opportunity cost is the one that is optimal. So if we're the EMPA, then the opportunity cost of holding the event is $1,000. If we're BYU, the opportunity of not getting their way. So if the MPAA isn't allowed to hold the event, then that's not getting their way. Their opportunity cost is $1,000. If BYU is forced to hold the event, that's not getting their way, and the risk value they'll incur is $900. That's like the opportunity cost of the $900. So the MPAA bears the higher opportunity cost, which is why it's socially optimal to do that, because they would stand to bear a greater opportunity loss than the university. Part C says, what should we expect to have happen if BYU has the right to dictate what happens? What do you think, John? It doesn't happen. Yeah. So unless, yeah, I mean, if BYU is going to be paying $900 in risk value and they're not even going to be getting the $1,000 of benefit, I can't imagine a situation in which that would be the case and they would let the MPAA hold the event. I guess if you could transfer, if as an MPAA presidency you said, but we really want to have this event, we'll pay BYU for their risk that they're incurring. We'll pay them $900 for the event, and we'll just take the $100 in surplus. Then that would be a way that you could maybe sustain like a win-win situation. Yeah. So review question number 2. Well, if you guys actually, if you want to, I'll give you a chance to email in questions real quick. If you have them. I just got an email requesting that I put up formulas because it's hard to see the board, and it looks like it was sent 6 minutes ago, but it just came through. I'll try and be more conscious of the fact that it's difficult to see the board for you guys. Okay, so I don't have any questions from you guys on that, so I'm just going to go on to number 2 for the review. Economic and accounting profit. Okay, so this is pretty similar to ones that we had before for this problem. So this is about my hometown. So you're a fiscal analyst for the city of Glendale, Arizona. You're analyzing a proposal to build a new arena for the Phoenix Coyotes. The stadium will cost $17 million. Okay. The city estimates that the stadium will last for 15 years. And that each year, the Coyotes will bring in $1.5 million in tax revenue. So that is one option. The other option is that a real estate investor has offered you $8 million for the parcel of land as it is. So you wouldn't have to pay anything for any stadium. Okay. So what is the accounting profit of building the arena? We just look at the accounting profit. We're going to do the cost of building the stadium. So the revenue that the stadium brings in minus the cost of building the stadium. So revenue it will bring in will be 1.5 million times 15 years. So it'll be $22.5 million. Minus the cost of building it, which is 17 million, or a total accounting profit of $5.5 million. Part B says, what is the economic profit of building the arena? So to get the economic profit, we'd want to do the accounting profit minus the opportunity cost and see if it's still the best option and if there's still a profit. So we have the total revenue it would bring in minus the cost of building it. You'd also need to subtract the cost of this offer, the next best offer. So $5.5 million minus $8 million is negative $2.5 million. So we see that there's a negative economic profit. If you look at the other opportunities that you could have taken, you're actually not coming out as well as you might have. And so it would be better to choose a different option. So when it says part C, should you build the arena? The answer is no, because it'll take you 15 years to earn $5.5 million in profit. And to earn this $5.5 million in profit for the accounting profit, or you can sell the parcel of land for $8 million, which would give you an $8 million accounting profit. And the economic profit from doing this option would be the opposite of this, so it'd be $2.5 million for economic profit. We'll choose this one. Because we'd be doing the total revenue, which is this times this, minus the cost. Well, yeah, so for the total revenue, minus the cost, minus this cost gives us negative economic profit. But if we just look at this option, minus the economic profit of the other option, we still get a $2.5 million economic profit here. Yeah, shouldn't build your renewal, you just sell the parcel of land for $8 million. Yeah, and it just makes sense, right? If you're only going to make $5.5 million in profit in 15 years, or $8 million in profit for selling an empty lot, we're profitable that way. Yeah, so we don't get any agreement with the coyotes. Okay, so I'm going to give you guys a chance to email in any questions or comments that you have on that. I tried to write a little bit bigger so you guys can see the board. Okay, I haven't gotten any question, guys. I'm going to move on to number 3. Not under review, just regular number 3 in problems at 7. About solar panel subsidies. Okay, so consider the market for solar panels. Let's say the government implements a subsidy. Graph the market for solar panels and show what happens when the subsidy is implemented. Okay. So I'm just going to graph simple supply and demand hypothetical for this problem. Okay, so we have a certain marginal cost curve. So that's the marginal cost curve of private companies. I'm going to also draw the marginal benefit that they receive. So if this is the case, then we have a market where the equilibrium is right here. At a certain P1 and quantity 1. The government is going to provide a subsidy, which is going to bring down the marginal cost for those producers. So I'm just going to shift this marginal cost curve down. And so the government is providing a subsidy because with their understanding, there is a different marginal cost curve socially than there is privately for these companies. So it may be the case that it costs companies a certain amount of money to supply solar energy. But in addition to the costs they're incurring, there's a social benefit associated. And so the government is trying to get it to a point. So if this is the true place where when you're taking into account all social benefit and the company's private benefits and costs and everything, then the government wants them to go from producing at this point to this point. And to do that, they're going to they're going to implement a subsidy. We have at this new point where the government wants them to produce, we have P2 and P2. So this is the new quantity and new price where the government would like them to get to. Then we're going to look at the place on the marginal cost curve. So the government is going to have to provide this quantity of subsidies, and they're going to have to provide it at the difference in cost between the marginal cost curve for private and the marginal cost curve socially. So that difference is represented by this length. And then to find the total cost of the subsidy, you just want to find the area of this cost times this quantity. So it would be this cost times this quantity. And this whole area here represents the subsidy size. Yeah. So this entire green section would be the subsidy. So what happened to the equilibrium price and quantity? We see this was the original equilibrium price and quantity when it was just the marginal cost of the producers and their marginal benefit being considered. The government saw that there was a marginal cost curve that was lower for just socially, with everyone included, and so they wanted to get to this point that they saw as a true equilibrium if all those costs are being taken into account. But in order to do that, they had to provide a subsidy to those private producers, which is in the area of this rectangle here. So the equilibrium price went down and the equilibrium quantity went up. Mm-hmm. Okay, so the dead weight loss before the subsidy, there would have been a dead weight loss before the subsidy because they weren't taking into account, um, because producers wouldn't have been taking into account this true social cost. They would have only been looking at this social cost. They would have only produced to this point, right? So then all of these areas in here, which I will color orange. So then if they were producing at this point when they were only thinking about themselves, they would have never produced in here. But according to the social marginal cost curve, they should have produced those points. And so this is the dead weight loss before the subsidy. And after the subsidy, there is none because we're at the correct equilibrium. So there is no dead weight loss for the subsidy. Yeah, you could do that. So it says label the dead weight loss. You could maybe just mark and say before the equilibrium change, there was a dead weight loss, but now that there's a subsidy, there would be no dead weight loss. Which isn't to say that there's no cost of the subsidy, right? Like the cost is a very large area in comparison to the original dead weight loss. So there, you win some, you lose some, I guess. Yeah. Okay, so I'm gonna send in any questions you have real quick, guys. And if I don't get any, I will just move on to number 4. Yeah, that would be the one after 4. Okay, guys, I haven't gotten any questions from you, so I'm gonna move on. Okay, we're gonna move on, guys. Okay, so we have, I'm going to move on to, let's see what number is it? Number 4. Okay, so you're studying a proposal by the city of Pasadena, California to tax fast food because of the litter it creates. Okay, so it's going to so they're just going to tax the fast food because it increases revenue. Okay. Okay, so we're going to, apparently in class, Dr. Curley said to just say instead that we're studying a proposal by the city of Pasadena to tax fast food because of the revenue it creates. Okay, so demand is given by $180 minus 40p. And supply is given by negative 20 plus 10p. Okay, so I'm going to set E equal, or I'm going to set Q equal to 0 so that I can figure out where the price intersection point is going to be on this y-axis. So when Q equals 0 for quantity demanded, it's going to be 180 equals 40p. So P is going to equal 4.2. So for quantity demanded, I'm going to do that one in purple. And the price intercept point is going to be um, $4.5. Okay. And for quantity supplied, I'm going to solve that one for P or for Q equals 0 to find out what the price intercept is. So it's going to be 20 equals 10p or p equals 2. So that intercept is right here. And then I want to find, if I want to draw their lines now, I can set these two equations equal to each other to find out what the equilibrium point is going to be. So we got real quick. So let's see, 180 minus 40p equals negative 20 plus 10p. So I'm going to add 20 on both sides and get 200 over here. And I'm going to add 40p on both sides and get 50p over there. So it's going to be 200 divided by 50, so 4. So that's the price point where they're going to intersect with one another. I want to also know where that quantity point is located. So I'm going to erase this and figure out what the quantity is for. So if price is 4, then you can do negative 20 minus 10 times 4. So we get plus 10. So we get negative 20 plus 40, which equals 20. So that is the Q value for where they intersect. Put it right here. So that intersection point will be right here. For Q quantity demanded, and right here for quantity supplied. Okay. So per day, we graph supply and demand. We also have part B, which is the equilibrium price and quantity before the tax. Okay, so now for part, for the next section of the problem, it says, now suppose the city implements a $1 tax. Graph the market after the tax is imposed on the same graph. Okay, so so the tax is going to increase the So essentially, the tax is going to increase the price of supplying by $1 at every quantity point. So we're just going to shift up the supply curve, keep the same slope, so the same same slope, but we're just going to increase it by a value of 1. So our new supply curve would be something like that. Call this QST for quantity supplied with tax. So I want to know, what's the new equilibrium quantity? We're going to have to figure out the equation for that line to figure out what the new equilibrium quantity is going to be. Okay. So before the tax, we knew that this point was quantity 20, price 4. And we know that on this line, that that point is going to be still price 20, still in the same quantity, but the price is going to be 1 more, right, for the $1 tax. So that's one point that we know about on that line. We also know that it has the same slope as this line. So we can use that fact, or we can use these 2 points to calculate the slope, or the equation for that line. How would you write the equation for this line? So the equation for this line would be, I'm going to write it with, so we have Q equals, I'm going to write equals, so I can use y equals mx plus b, and then afterwards I can rearrange. So p equals, so p equals the same slope as this, so 10p. Oops. I'm actually going to use, so p equals 3, so that's my intercept, plus my rise over run, right? So which is going to be rising 2, go from 3 to 5, and over 20, because we're going from 0 to 20. Right? We get p equals 3 plus 1 and 2. If I want to rearrange this so that I can look at it like one of these equations, I can do that. So I'd have p minus 3 equals 1/10 q multiplied by 10 on both sides, 10p minus 30 equals q. And that is a quantity of supply with tax. So that's the equation of the new line, of this line here. The quantity of supply with the tax. So we're going to resolve this. Put this up here. The supply with the tax is 10p minus 30. If I want to know what the new equilibrium point is, this point right here, I just set those two lines, this line and this line equal to each other now. So I would get 10p minus 30 equals 180 minus 40p. What am I doing there? So just to reiterate, right now I'm setting this equation equal to this equation so that I can get where this line equals, where these two lines intersect. Yeah, so there's the new equilibrium point. Okay, so I'm going to subtract 10p on both sides, or no, I'm going to add 40p on both sides. Get 50p over here. I'm going to add 30 on both sides. Get 210 over there. Okay, so p equals 210 over 50. For 4.2. So this new price right here, this new equilibrium point, the drop way out here, is 4.2. The new quantity we would get just by plugging that 4.2 into one of the equations that we just used. So I'm going to plug 4.2 in for right here. No, I didn't use that for this. Okay, so Q equals 10 times 4.2 minus 30. So 42 minus 30 or 12. So this point down here is 12. So that's the new equilibrium point with the tax. They're going to sell less and it's going to be more expensive. Yeah. So is it talking about the tax burden there? I think it is. Okay, so yeah, so consumers, okay, so at the new equilibrium point here, consumers are going to pay $4.20. What producers are going to receive is going to be $1 less than that. So they're going to actually still be, this is their supply curve. They just had to add $1. So they'll be receiving $3.22. So that's part C. What price will consumers pay? The $4.20, and producers will actually receive $1 less than that. So they'll receive about $3. What is the tax revenue? So the tax revenue is going to be equal to going to be $1 times the quantity that is purchased, right? $1 for every unit, 12 units. So it'll be $12. Oh, it might be. That would make more sense. I don't know if I put that in there. Let me look and see. Yeah, it's probably not in, that's probably not just 12, it's probably in the thousands or something. Oh yeah, Q is thousands of meals. Yeah, so it'd actually be $12,000. Okay, so that took us to part E. Now we want to know part F. What is the deadweight loss? What do you think, John? Do you think you could point to the area on the graph where the deadweight loss is? Oh, you have it there already. So equilibrium, true equilibrium is here. But now this is the equilibrium that we're finding. And so this additional quantity is not being produced anymore. This is all lost. The quantity went down, so that's the deadweight loss there. So to calculate the quantity or the actual value of that, we need to know the area of that triangle, which is going to be, yeah, 1/2. This is the length of the triangle, or the height of the triangle, I suppose, and that's 8 times this height of the triangle, which we know the difference between these two is 1. So the area of that deadweight loss is going to be 4,000. Yeah, because this is in thousands. So the deadweight loss is 4,000. How much of the tax do producers pay, and how much of the tax do the consumers pay? So who bears the burden of this tax? Well, they share. So yeah, the consumer is going to pay more than the producer. I'm going to zoom in on this part of the graph over here so I can draw a little bit better. Okay. So the original is 20 and 4, right? Oh, this is okay, and then the demand is something like that. Okay, so we want to know how much of this tax the producers are going to bear and how much of it the consumers are going to bear. So the price of the tax is represented by the area from the new equilibrium quantity times the difference in between these two curves, which is $1. So the area of this triangle represents how much the tax actually costs. Can you see that on the no. Okay, I'll use a different marker. Okay. So this is the area of the total cost of the tax, or the total revenue that the tax gets, depending on what you're looking at it. We want to know how much of that is borne by consumers. So part that's borne by consumers is the area between the old equilibrium point and above in this area. Yeah, so it'd be 0.2 times 12. And then I didn't really draw this very well to scale, because this part of this section would have graphically looked a lot bigger than that part up there. But so the consumer section is 0.2 times, which is this length, times 12. And that equals the consumer. The producer burden is down here. Which is given by which is given by the difference between these two curves. So the difference between these two curves is 1, right? And point 2 of it is representing this length of this rectangle. So this length actually should be representing 0.8, even though it doesn't look like it. It'll be 0.8 times 12. And it ends up being 9,600 and 2,400. If you multiply each of these by 1,000, then you get 9,600 for the producer burden and 2,400 for the consumer burden. Okay. Okay, everyone, so you can email me any questions if you have them. It is 10 p.m. now, so I'm going to end here, but I'm just going to finish up with any questions that you may have. Yeah, so please let me know. Okay, I'm going to go ahead and close out for now. I am going to be proctoring your exam on November 6th, so I'm going to come up to Salt Lake and do that. And for the first hour of that session, I think from 5 to 6, we're going to start your exam at 6, but if you want to come at 5, I'm going to host a review session for you guys up there. So I'm sure Dr. Turley will tell you more about that. So, but feel free to come to that. Okay, thanks, guys.